because after this one we move on lecture number 11, and 11 considered to be the extra reading. Extra reading, that means maybe the lecturer in our department, they don't ask question about the material of lecture 11. So that's why I say extra reading. I will tell the teacher in our faculty about this so that they know, okay? But for your long-term career, the knowledge, the understanding of the flow network problem today, we will learn today, will be very important. So that's why we have to consider this now, okay? Thank you. I see I see, but I don't see your name. Now I see. We, Pháp, Đức Danh, yeah, we. Where is Châu Thanh? Not Châu Thanh. I see Hồ Quang. I see Bảo Ân. Phú Vinh also no. Ngọc Hưng, no. Maybe you cannot turn on your camera. That's true. Yeah. Yeah. Some people say yeah. BC Trần Gia Linh cannot. Etc. We understand. Okay. Thank you. So now you can turn off. We go back to the lecture. And today and this Thursday as well. Don't forget this Thursday, the final review. Huh? Okay. 11. We have to open that one. About the flow problem in network. Mostly apply for directed draft, and you should get the file downloadable from our BKEL. I mean from the Google Drive. So a few more moments, I will show you the slide right now. I am importing the slide into the memory and show you. This one. So the tree we just learned apply mostly for the undirected draft, the spanning tree, minimum spanning tree for undirected draft. Although we have the weight in the draft, but now we talk about the directed draft. So that means the flow of information only can happen in one way. Yeah. The flow of material can be many things, okay? Material can be oil, can be car, in general can be vehicle, can be money in the banking sector, can be information in general, oil, etc. Car and vehicle on highway, etc., etc. Okay, so we define a draft now to be directed draft. So we will fix this notation. We use capital N for directed draft, with the connection, directed connection, and then the underlying draft we denote it by G, defined on the same vertex set, but we use capital E for the connection. And we understand that's the beginning of everything, okay, for lecture number 11. So this is the content of 11. We talk about the flows, and then we talk about the maximum flow. Then we talk about the problem maximum flow and minimum cost from that max flow. And then the major part, we discussed this one. The idea to solve the mass flow problem, and then we illustrate with one of the most famous algorithm invented by Froh and Fulkerson to solve that. Okay, and we finished lecture 11 today. The other application and the other problem you can read yourself later on from number 3 here. We have to cover only number 1 and number 2 down here. Okay, this is the learning outcome. Most important outcome we can get from lecture number 11 will be this outcome: ability to explain and to model problem by using discrete structure. Okay, then the algorithm also help you to optimize something from the flow. That's why we call the maximum flow problem. Application a lot I mentioned to you there, but here in the slide we can talk about the manufacturing. We define the production capacity of some large company, production company, maybe like Honda car company, or some other enterprise to produce household product, or airplane or something like that. And the scheme for any factory can be visualized in this one. Generally, you put here to be the input, defined to be the raw material, and the flow of raw material will run through many departments here, and you can write the number up here to mention the time the raw material will be processed in each department. Okay, then after you get some partial result, the raw material just a tiny reduce, so that means we need to move the next department I mean the flow of raw material must be transported via many intermediate department like this, and let's say go in M6 48 hours, then go to M7 61 hours, etc. So basically you want to know how much time you finish the process and get the complete commodity or complete goods, and then you can transfer to the market to sell, okay, or to export to other country. So this is the typical diagram for the flow in directed network, okay. Any connection here must be directed. The flow of material only one way, only allow moving one way. Then you can model by using logic as well, like this one, okay. So you can have two ways to look at, either by graph or by look to this logical expression. M1 and M2 must be done, must be buffered before. Where is M2? I don't see M2, M1, M4. Yes, M1, M4 here. Yes, M1, M4. In the sequential scheme before moving to M5. Or you can also allow moving from M2 to M5. So that's why we employ the OR operator here, you see. And either you finish the first upper part or you finish M2, then you can do M5 and M5 here with the AND operator. And if you finish M5, one part, the second part coming from here, M3, M6, again, the AND operator, you see the AND operator. So that means in the future when you go to work for industry, the draft theory and the logic theory should go in hand together to help you to solve optimization problem like this. So this is the beginning of everything. So we have about 40 minutes, so I have to finalize very quickly the idea and also the algorithm. So let's follow me, right? We want to solve just specific problem from here, because in general there are so many problems which we can formulate from that motivation. Therefore, we limit ourselves to very specific problem here, where we call the maximum flow with the input like this. I give you a directed draft with the vertex set and capital A here in the set of arc. So that is the difference between the two A and E, right? A and E. A mean the set of arcs. Arc mean directed connection, you can say that. Only one way. Then E mean the usual connection.